Ever wonder why volcanoes pop up in the middle of the ocean, far from where tectonic plates collide? It turns out, continents aren't as solid as they seem. Deep beneath the surface, they are shedding pieces that are sinking into the ocean floor, sparking volcanic activity in unexpected places. This groundbreaking discovery is reshaping our understanding of how our planet works. Geologists have found that fragments of continents detach and descend into the oceanic mantle, the hot, mostly solid layer under the seafloor. This process triggers volcanic eruptions far from the usual tectonic plate boundaries. But how does this happen? It all comes down to the strange chemistry of ocean volcanoes. Typically, volcanoes are born near tectonic plate edges, where Earth's surface slabs crash or split. However, many volcanic islands, like Christmas Island in the Indian Ocean, defy this pattern. Their lava contains elements usually found in continental rocks, not oceanic ones. Initially, scientists thought that this strange chemistry came from ocean sediments being pulled deep into the Earth by sinking tectonic plates. Others suggested mantle plumes, columns of hot rock rising from deep within the planet. But here's where it gets controversial: neither explanation fully accounted for the evidence. Some volcanoes didn't show signs of recycled crust, while others were too shallow or cold to be plume-driven. So, what's the answer? Researchers now believe that a slow but powerful force deep beneath the continents is at play. When continents begin to break apart, like when the ancient supercontinent Gondwana split over 100 million years ago, the movement doesn't just crack the surface. It sends stress waves deep into the mantle below. These waves can strip away parts of the continental base, up to 125 miles deep, and drag them sideways into the oceanic mantle. This process is incredibly slow, moving at a millionth the speed of a snail. Yet, over tens of millions of years, these detached chunks travel hundreds of miles. Once in the oceanic mantle, they become part of the magma factory that fuels ocean volcanoes. The study, led by Professor Thomas Gernon at the University of Southampton, sheds light on this process. Professor Gernon explains, "We've known for decades that parts of the mantle beneath the oceans look strangely contaminated, as if pieces of ancient continents somehow ended up in there, but we haven't been able to adequately explain how all that continental material got there." To investigate, the team created simulations that mimic how Earth's mantle behaves during tectonic breakups. The models revealed that when a continent splits, it creates instability deep below, sending a ripple along the bottom of the continent, called a mantle wave. This wave peels off fragments of the continental root, sweeping them into the surrounding oceanic mantle. Sascha Brun, a co-author of the study, noted, "We found that the mantle is still feeling the effects of continental breakup long after the continents themselves have separated. The system doesn't switch off when a new ocean basin forms, the mantle keeps moving, reorganizing, and transporting enriched material far from where it originated." The team focused on the Indian Ocean Seamount Province, a chain of underwater volcanic mountains formed after Gondwana's breakup. The study showed that soon after the breakup, magma rich in continental elements surged up from below. Over time, this signal faded, indicating that the source material had stopped arriving. And this is the part most people miss: this happened without a deep mantle plume, the usual suspect. This points to a different process, the one shown in the simulations. Professor Gernon emphasizes, "We're not ruling out mantle plumes, but this discovery points to a completely new mechanism that also shapes the composition of the Earth's mantle." Mantle waves can carry blobs of continental material far into the oceanic mantle, leaving behind a chemical signature that endures long after the continents have broken apart. This research team has previously linked mantle waves to major planetary shifts, such as diamond eruptions and landscape reshaping far from tectonic boundaries. This new study adds another piece to the puzzle of how Earth works from the inside out, showing how the remnants of ancient continents still influence our planet. The full study was published in the journal Nature Geoscience. What do you think? Does this new understanding of mantle waves and continental fragments change how you view the forces shaping our planet? Share your thoughts in the comments below.